Awesome. Thank you. Hi, everybody. I'm Doug Sillers. I'm originally from Seattle, Washington in the US, but I'm traveling with my family through Europe, and I want to thank everybody for coming out and listening to me talk about how to speed up your mobile experiences and how to make sure that things run really nicely when you're building mobile experiences. A little bit about myself. I'm doing freelance developer relations, which means I help companies figure out how to talk to developers, because a lot of people build APIs and then their documentation is horrible, or they're trying to get information to developers, and I try to help them figure out the best way to make that communication work well. And it's a two-way street, right? Developers will tell how to improve it and all that sort of stuff. I've also worked in performance for many, many years. So speeding up native apps, speeding up websites, and I do audits for different companies on how to speed up their tooling. And today I'm gonna give sort of a general talk about performance, but I also specialize in image performance and also video, because video is becoming really a big thing on both mobile apps, mobile web, any web. If you ever have any questions about the talk or anything else, I'm the only Doug Sillers on the internet. So like my Twitter, my Gmail, my website. I'll put the slides up on my slide share. They're all Doug Sillers. Before we start talking about speeding up mobile applications, how many of you sort of get the butterflies in your stomach when you think about walking across this walkway that's nailed to the side of a mountain in Switzerland, right? It's kind of terrifying. I did that with my family, and my 6-year-old jumped the whole way, so it kind of moved the whole time we did it. But about 2 years ago, Ericsson did a study, and they put sensors on people's brains to figure out how people responded to stress. And they found that queuing up for a line increased people's anxiety and their stress. They found that thinking about walking on the edge of a cliff raised people's stress and their responses. But they actually found that slow mobile experiences are more stressful than standing on the edge of a cliff. So if you build a slow mobile experience, your customers, your users, are feeling that thing you were just feeling about 3 minutes ago. And if we can make sure that they're not feeling that, that will make them happier. And happier customers buy more stuff, use your site more often, use your app more often. So those are all good things to do. So when there's a slowdown, Google found that a 3-second delay causes 53% of people to abandon mobile websites. Another site, a half-second delay increases frustration, lowers engagement. Walmart and Amazon found that people spend less money when they are on a slow site. Maybe they can't click to as many different items, they buy fewer things. I just read a tweet today that they're expecting mobile browsing during the holiday season this year to be bigger than all e-commerce 3 years ago. So on mobile, it's going to be huge. And then 4% of mobile users admit to throwing their phones when there's a slow mobile experience. So our customers are demanding these things, these fast, immersive, rich experiences, and you're trying to download all of this stuff, and sometimes it can't get there fast. So what I want to talk about is ways to improve the delivery of content so that it's fast. But one of the problems is cellular is high latency. There's a lot, every round trip to a server is very slow if you're on a cellular connection. And we built a tool. I used to work at AT&T in the States, and we measure the packets coming in and out of every single application, and then we can look at the performance of all of that data. But if you look down here, this is modeling the cellular radio. And the cellular radio stays on after the last packet, because establishing a connection can take 2.5 seconds on 3G. It can take 1/4 of a second on 4G. And then every round trip for packets is between 100 and 200 milliseconds. So we've got a lot of delays. So carriers will keep the radio on for a period of time. Now, the problem, of course, with keeping the radio on is, I'm charging my phone right here because my battery's low. We charge at work, we charge in the car, we charge at home. We have battery packs in our backpack to charge. If we keep the radio on all the time, we're going to drain out our customers' batteries. So if your app is constantly pinging in the background, or if your website is constantly sending analytics or something, you can sometimes never turn off the radio and add battery drain to your application. So I'm going to talk about some of the tools that I use to find problems with apps and with websites. I'm going to look at some of the best practices that have been developed to speed up those things. And then we're going to look at some fixes. So as I mentioned, for many years, I worked on a tool at AT&T. It tests iOS and Android apps. It's called Video Optimizer, and it runs network traces on your phone to see what's coming in and out of the apps on your phone while you're testing. And then Web Page Test is a tool that you can use for looking at your web pages, and you can test on real mobile devices or your own mobile devices to see what's going on. And you get audits and reports to figure out ways to speed up your apps. So when you use Video Optimizer, you plug in your phone to your computer. Here I'm testing with a Samsung device. And there are all these parameters. One of these, it lets you slow down the network speed. And slowing down the network speed is important because here in Barcelona, you've got great LTE. It's going to be fast all of the time. But not everybody in the world is on LTE. There are a lot of people stuck on 3G. And some people out there, you go out in the mountains or something, you're on 2G. People still want stuff to load quickly. I spent a month in very rural Ireland this spring, and my Airbnb said that it would have Wi-Fi. But it had Wi-Fi connected to a 3G router that was mostly on edge. So, did I have Wi-Fi? Sort of, but everything was incredibly slow. Until 1 a.m. when everybody's smartphone went to sleep, and then it was really fast because there wasn't as much congestion on the network. But it is important to see what your app looks like on a slower network. Facebook has a thing called 2G Tuesdays, and they turn the Wi-Fi down in their office so that you have to use the app on a slow speed. We record the video when you're running the trace, and then you can test. And so here I'm testing an application, and if you look up in the corner, there's a key, which means there's a VPN running, and that VPN is how I'm capturing the data traffic coming in and out of the phone, so I can see what traffic is being sent by the application. So I can test the application, do everything I need to do, and when I'm done, I press stop. We want to make this really easy for people to use so they can find out what the problems are in their app. All of the files that are collected on the phone are copied over to the computer. And usually when you take a network trace, anyone here use Wireshark? All right, Wireshark's a really awesome tool. Even if you use it every day, you're still learning new things because there's so many features hidden behind different, the different options and the different things you can do. We wanted to make it a lot easier. So we came up with 40 best practices. And the goal is green check mark means you passed and red X means you failed. So there's room for improvement. And when you get a red X, we show you where you failed or where in your app there was a failure so you can improve your application. Web page test is kind of the same thing. There are sites all around the world, so you can test anywhere around the world. Here I'm testing in Virginia because they actually have Android devices you can test on. So I'm actually testing on a Motorola G4 using Chrome in this location. I can have all these parameters. I can change the network speed, the number of tests, and there are a bunch of parameters behind all those tabs, and you get results. And so here's a web page that I built that's really, really slow. Even on Chrome, desktop Chrome, it takes 19 seconds to load. I built it to be slow. And the reason it's slow is it's downloading 11 megabytes of images, right? It's a really slow website. But you get all these results, and it walks you through ways that you can optimize your website. So one thing you can improve when you're delivering content is the number of redirects in your application. How many times the website points to a different location to download content. And this happens with a lot of websites. For example, the first time you hit google.com on your phone, you get a redirect to the www.google, which then redirects to the HTTPS Google. And you see the first time you hit google.com on your phone, there's an added 2 seconds of delay in the browser to hit that site. These are both now cached the second time you hit that URL. So if you hit google.com a second time, it loads extremely fast because those redirects are stored locally on the phone. You don't see those again the second time. The first one is because it's a permanent redirect, so it's cached. And this one, now that they have HSTS, it's all cached. But the first time you hit the site, actually web page test gives Google an F. So it's interesting that these things happen to really big websites, and it's something that you can look at to improve your app or your site. Now, in a mobile app, I've seen the same thing. I was testing a music streaming application, and you can see I got a red X for 301, 302 redirects. And in 10 minutes of testing, there were 240 redirects. And this application, every time it tried to download the album art, it was redirecting, and the album art wasn't there, and it was redirecting to another place to download the album art. And it added about 1 minute to a 10-minute test. About 10% of my browsing time was taken up by redirects, just stuff loading on the page. It felt really, really slow. To make things worse, we have another test looking for 404s, and 33 of those redirects ended up going to a 404 error. And obviously, we want to avoid 404s because that means the content is actually not even there. But my favorite response code that I've seen sometimes is HTTP 418. Does anyone here know what HTTP 418 is? I'm a teapot. Yes. So I am a teapot is it's an April Fool's joke, because 20 years ago, people connected coffee makers to a camera so they could see if there was coffee in the break room, so they wouldn't have to get up. And so for April Fools, they added a 418, I am a teapot. And I like this because some web engineers, like, this is the funniest joke, knowing the only person who will ever see it is someone like me looking at their HTTP headers. Like, it's totally like this engineer joke just between engineers. But about a month ago, NPM was migrating from Fastly to Cloudflare, and for some of their, they were doing all these migrations, and for some of the errors, they thought, well, we'll just make a fun error because it's never going to happen, and they called it 418, and there was an issue with the way they were doing port migrations, and about 5% of users using NPM were getting 418 errors when they were trying to make their builds for about 2 hours one day. So it actually does show up in the wild sometimes, and actually it's neat to see. But what can we do to speed up delivery of content? I'm going to give an example here of a native application where third-party apps, third-party plugins and analytics were getting in the way. So I'm trying to watch a TV show in this application. I click the button and I have to see an ad. And we all kind of hate watching ad interstitials, but that's just part of the way the internet works these days. But here's the network trace. And so these are all the packets coming in and out. And right there is the video, because this is throughput. And obviously, videos are really big. So that's the that's the video being downloaded. But you can see right here, there's a lot of stuff being downloaded before the video. And what's all that? Why is that slowing down my video from downloading? Here are all of the connections, right? This is sort of like Wireshark, all the TCP connections. Right here is where I said, show me the video. And right there is the video, which we can see because it's like 5 megabytes, right? That's the connection. So all of these connections in between, it turns out they're analytics. And so this app was studying the video playback so closely that they were firing up all these third-party analytics engines, and it was adding 2 seconds to the ad starting to download on a fast connection. And on a slow connection, this was actually 4 or 5 seconds before the ad's downloading, which means that the delay of the ad actually starting to play was somewhere between 4 and 10 seconds. So you click the button, you have to wait, and then you have to watch an ad. And then what do you think happens after the ad finishes playing? Do you think they've preloaded the video? No, they didn't preload the video. So the ad plays, and then you have to wait another 10 seconds or so before the video actually starts playing. Do you think they were losing people? Even if you really want to watch that TV show, eventually you're like, this is really slow. You may not watch a second TV show with this app. So they fixed a bunch of that. The other thing we can do is we can optimize the delivery. So when you buy something from Amazon, you get a big box and you open it up, and a lot of times there's like 15 meters of brown paper, and you pull it all out and you find that your kid ordered a pencil. This happens to us all the time. I mean, it just happened to everybody, I'm sure. And I think a lot of time, and we think like, why the heck did we get this giant box with all this stuffing just for one little tiny thing? And a lot of the content we deliver on the web is delivered exactly the same way. So if we look at the average website is 25% text files, CSS, JavaScript, HTML, fonts, etc. It's 50% images and 25% video. So I'm going to look really quickly at different ways we can optimize all of these different things. So here's another video streaming app. You fire it up and you expect, all of these TV shows to have pictures and all this content. And it's all populated by this tiny little 130 kilobyte JSON file. And that JSON file, it's an American app, so it's got America's Got Talent, the URL for whatever is going onto the screen, right? The problem is, of course, they didn't compress that JSON file. If they'd compressed it, it would just be 16 kilobytes. So it's going to download a lot faster than 130 kilobytes. If you use Brotli, which is a little bit more modern than gzip, but it decompresses just as fast, you can get it down to 12 kilobytes. That might just be one round trip, right? It's just one, you request it, it downloads. You can start making the requests to populate this screen. But it's going to take a lot longer to download. It's hundreds of milliseconds, but it's still making this page load more slowly. So just by compressing text files, that page is going to be delivered faster and people can interact with the application faster. Images make up a lot of the content we have on the internet today. I'm going to talk first about SVGs, vector graphics. Vector graphics are awesome because you can build this with XML. It's just drawing shapes. You can stretch it. You can make it small. It's always like, for a graphic like this, usually like 500 bytes, maybe a K, maybe a kilobyte. And it always looks great. And I found this on a website in Brazil. And you can open up the XML, and it looks something like that. But if you look down at the bottom, you see this Adobe Illustrator thing at the bottom. And there's a lot of it. And when I remove it, the file goes from 1.3 megabytes to 900K. So they were doing the right thing. They built this Facebook logo in Illustrator. They exported it, but they didn't clean it up, and they just posted it to production. And so this web page has 5 images that are about over a megabyte each, and they should all be under 1 kilobyte each. And so this just goes to show that you can do the right thing, but if you don't test it, you can still push the wrong stuff to production. And obviously, if you zip it or you use Brotli, you get it to like less than half a kilobyte. So you can just inline that in your HTML super fast if you do it the right way. This is another application, another Android app. I'm looking at different pictures of Frank Sinatra. And let's look at the picture in the bottom left-hand corner. And if we look at it, it's 1.8 megapixels. And it's 1.5 megabytes. So imagine 6 images at 1.5 megabytes on a slow connection. This page is going to take a really long time to render. What can we do to speed that up? We can resize the image to the size of the screen, right? The screen is 1440. Make the picture 720 wide. You can see we've cut out from 1.8 to 0.4 megapixels. So we've cut out 75% of the content. And lo and behold, the image is 75% smaller. Another thing we can do is Google recommends that all images be saved at 85% quality. You're removing some of the pixels, but you're making the file smaller. So it's a good balance between quality and size. And when I make that 85%, the in the corner starts to look like that. So the quality is reduced, but no one's going to notice the difference. And again, it's down 64% savings. Now I can do both of them, right? Apply both of these fixes at the same time. And now the file's under 200 kilobytes, almost 90% smaller with just 2 simple changes. Great way to make images a lot smaller. I went and looked on the web using Lighthouse and the HTTP archive. Lighthouse is in Chrome DevTools. Anyone use Lighthouse when they look at web pages? It's an audit of mobile websites. It helps you figure out how to optimize your websites. The HTTP archive does this for 1 million sites every 2 weeks, so you can then go and run queries on the data and find out what's going on. A full 1/3 of the web are not saving their images at 85%. They get a 0 score in Lighthouse, which means that these pages could shave off, I think I have the data here, about 400 kilobytes, and they'd be about 2.8 seconds faster on mobile. And that's pretty huge, right? That's a pretty huge improvement to speeding up a website. There are other tools. So this is a tool called Cloudinary. It's cloud-based. You upload the full-size image, and then you can just change parameters in the URL. So I can set the quality to 85, the width to 720, and it generates that for me on the fly. I can probably go lower than quality 85. And there's another algorithm you can use called structural similarity. And it's an algorithm that says, what can the human eye see, and how low can I go on the quality before anyone tells the difference? And if I do that, I use Q Auto, and I shave off another 50 kilobytes off that image, right? So this file is getting smaller and smaller and smaller. And then, because we're talking Android here, we can use WebP, because WebP is it's a Google format. It's supported in Chrome. It's supported for Android. It is also in development for MS Edge, and both Safari and Firefox are looking at supporting it. Now we're down to 84 kilobytes, 95% smaller. Now 84 kilobytes is going to download really fast on a mobile device on almost any connection, way faster than 1.5 megabytes. And there's the support, right? So WebP has Google support right now. But it is coming soon to a bunch of other browsers. So this will be a pretty standard image format for all modern browsers very, very soon, which is pretty exciting. Now, I talked about optimizing the size, and I gave you the size exactly right for my phone. But these are all the Android devices that hit the internet on a given day. This is about a year old. There are 6,600 Android devices here. The size of the box is how many. So these are all Samsungs. And then these are all very obscure, rare devices that we've never heard of. The color is how fast the CPU is. So green means they're really fast. Out here, there are a lot of very rare, obscure Android phones that are really slow. And we have to think about that. When you download a big image, if the CPU has to process it to throw away a lot of pixels, these phones are going to take a lot longer than these phones up over there. Has anyone heard of Android Go? All right, so Android Go is this new thing, so low-powered phones can run the latest version of Android. They all run, you can buy them in the store now. I was just in the UK, and they're running about 60 for an Android device running Oreo, but you kind of get what you pay for, right? If you're spending 60 euros for a phone, it's sort of like when you go to the supermarket and they've got phones for sale in the supermarket, right? You know it's not the best phone if I'm always, oh, that Samsung, that's 1,000 euros. And this one is 7 euros. Like, there's obviously a difference in quality there. And they're selling them in Europe. It's the #2 market for these phones is the United States. It's not like these are going to be in countries where people aren't using our products. They're expecting Android Go to be the #2 market to be the United States. The supermarket phones, the pharmacy phones that you can buy. So what do we do when we have all these different screen sizes to optimize images? On the web, you do something, you use responsive images. And so you have a bunch of different sizes, and depending on the screen size, you serve the right image from your server. And rather than look at the code, I have a demo right here. Let's see if I can find my mouse. Is it over there? Somewhere? All right. We'll make this work. Wrong way. There it is. All right. So what I'm going to do is I resize the screen here. The right size image will display. If I can find, there we go. And every other image is color versus sepia. They're all 25 kilobytes apart. So for a tiny little phone, you get this image is about 25K. For a bigger device, you get this image, it's about 200 kilobytes. And you're optimizing that image for the size of the screen. And obviously in Android, it's a lot easier to do because you know the size of the screen. You can just request that image from the server. When you're doing it on the web, you may not know the screen size, so you have the browser select. And again, I'm using Cloudinary. I'm just setting the different widths right here. And then every other one, I set a sepia parameter, and so that's being done on the fly too, which is kind of cool. So sending down the properly sized image will really speed up the content. Just because you don't have to send down that 4 megabyte or that 3 megabyte image, you're actually sending the right number of pixels to the device. Another popular thing today are preview images, where you download a purple thing instead of the cat dressed up like a princess, or green instead of the cat dressed up like a dragon when you search for cats in costume. And so this happens on a lot of different websites. They're just downloading an SVG of one color. And so as a user, you know an image is coming. You can browse through the entire page. It's already laid out, so you don't have to worry about images changing the size of the screen as you're downloading. So people are really used to seeing this. There's a cool tool that will do SVGs of your image. So this is a preview. You can see it's not just green. It actually sort of looks like the waterfall, sort of, with a couple of rounded shapes. And the reason this is important is a recent study found that most people don't scroll when they visit a web page. 57% of users only look above the fold and never scroll on the web page, right? So if you're downloading a web page that looks like this, you can maybe not even load those 4 images, and some people will never even see it. This is going to load a lot faster initially if you're only loading 2 images. And then if they scroll, you just use some code to download those images when it's showing up on the screen. It's called lazy loading on the web. And so there's a lot of really, it's a great way to do it. You can do it with JavaScript today. And most of the internet is not doing it. 60% of the web is not doing this. Most native apps are not doing it. It's a great way to speed up applications. Chrome is doing some neat stuff right now. So if I load that really slow web page I was showing you earlier that takes 19 seconds to load, if you load it, you can see how the page loads over time, right? So images like halfway down the screen are randomly loading before images at the top, right? And it slowly fills up. And the text finally reaches its final destination right there. But they're now making lazy loading run in Chrome. And so this is behind an experimental flag. But the entire page lays out really, really early, and it puts placeholder images in place on the whole screen. And you can then see the images load from top to bottom as the page loads, which is really, really cool. So it's more the way people look at the page is the way the images are loading. Another thing that causes a lot of delay on mobile apps and websites are animated gifs. Because I took this movie of my goat. This is Nora. And there she is, and I took that with my phone, 1.4 megabytes. When I make it into an animated GIF, the problem with animated GIFs is it's almost 300% larger. It's 3.8 megabytes larger. And the reason for this is GIF images don't compress through the time dimension. They're just static GIF images, played at 15 or 20 frames per second or whatever. And that's because, it's from the 80s, it's 256 colors, it's really great. So what happens if I make a video, I make it 256 colors, because that's all GIF supports. It's 250 kilobytes, same video. And now I can serve it as a video. Now video is the last thing to load on a browser, because browsers know that video is slow and they're really big, so it's always the last thing to download. But if you set your video to autoplay, loop, and muted, it will just loop over and over and over again on the web page. On mobile devices, you have to say muted, and I think that's so that when we're in meetings and we're browsing the web when we're supposed to be paying attention, and a video starts playing, it doesn't play really loudly, so we get busted that we were not paying attention in the meeting. You can put video MP4 files inside the picture tag. And this will actually run on Safari. So for iOS, for any Safari user, it will actually loop this goat video as opposed to the animated GIF. And so I imagine this will come out to other browsers as well, because 250 kilobytes is going to download a lot faster than 3.8 megabytes. So this is probably going to be the future. I also, I show an animated WebP for Chrome, and that's 3 megabytes. So 250K, 3 megabytes, 3.8 megabytes. There's a huge difference in how fast these things download. Finally, let's talk a little bit about video and how we can speed up video. People act the same way for video that they do towards websites and apps. If it's slow, they get frustrated. And of course, we know if they get frustrated, they throw their phones. So that's why I have this photo here. How do they get frustrated? This study shows that everyone will hang out for 2 seconds. They'll press play. You'll keep 100% of your users for 2 seconds. But every second afterwards, you lose almost 6% of your users. So the longer you make them wait, the more the people will abandon. And it's different for different types of videos. So for shorter videos, they abandon faster. So if you are sharing a video of a cat dressed up like a shark on a Roomba chasing a duck, after about 3 seconds, they're like, what the heck did I click on? And they start questioning their whole life in existence, and they move away. But if you're watching a TV show, you're watching a movie, you're gonna be sitting around for an hour. You'll wait an extra 10, 15 seconds in general. Things you can do to speed up delivery of your video content. On the web, you can set preload equals auto, so download that whole video. Unfortunately, that means that whole video is always downloaded on that web page whenever anyone uses it. Have you ever been to a web page, seen a video, and you're like, well, I'm on cellular. I'm not going to watch that video because I'm on a mobile connection. In this case, this web page decided for you. It downloaded like 25 megabytes of video, whether or not you watch it. So if you think about that as a developer, your company is paying for all that to come out of your content management system. And so it can cost your company a lot of money if you automatically deliver the video and there's a low probability that it's going to be watched. This is great if you think the video is going to be watched, but if no one's watching it, it's probably better to use metadata, which downloads the first couple % of the video, or video preload equals none. Don't download any of it. If they press play, start downloading the video. If you embed a YouTube video on your web page, none of the video is downloaded. YouTube waits until you press play to start downloading the video. If you embed YouTube on your web page, you get 600 kilobytes of JavaScript from YouTube, but it doesn't download any video. When you stream video, you get a manifest file. So a stream has lots of different bit rates that are available, so it can serve the right content for your network connection and also for the type of device, for the dimensions. The player picks a stream, it starts downloading those segments, and the video plays, ideally. This is what a manifest looks like. And so you can see it lists the different bit rates, the resolution. So this is 8.5 megabits per second. It's 1080p video. And the way HLS streaming works is it always picks the first stream. That's just, they have to pick something, so they always pick the first one. In this case, it's going to be 8.5 megabit per second video. And what do you think about most mobile connections? Do you think we can support 8.5 megabit per second video? In general, no. And so what happens is it's trying to download it. It starts taking a long time. And the player knows if it takes a long time, I'm going to lose my customer. So it changes the bit rate. And we can see this. So here it's downloading the 1080p video, and it's taking a long time. This is the first segment. It's taking a long time. It drops to 600 kilobit per second video. Starts downloading segment 0, 1, 2, 3, and then it goes back up to a higher quality video. So what most companies do is instead of using the highest bit rate first, they start with the lowest possible bit rate. In this case, it'd be 200 kilobits per second. And you've seen this before when you press play and it's all pixely for like the first 4 or 5 seconds, and then it sharpens. The player is trying to start really fast by downloading really low quality video, but it's playing, right? If it's playing, you'll hang out. If it's not playing, your customers leave. So get it playing, and then once the player has a better idea in the network connection, it can jump to a different bit rate and play a higher quality video. And if you think about it, most videos on the web, the first 3 seconds don't really have any content anyway. It's all intro stuff, so you can get away with that. Amazon does it a little differently. They always start with a middle-of-the-road bit rate, one that's pretty good quality. They know it'll take a little bit longer for it to start, but if you're on Amazon Video, you're watching a 20-minute, show, you're watching an hour-long show, they know you're going to wait a few more seconds. And when you start an Amazon video, it always looks great from time 0 because they download a higher quality bitrate to start with. But in general, don't start with the really high bitrate because on mobile and actually on a lot of desktop connections, you can't handle that bitrate. It's going to make it take longer to start, and it's still going to have bad quality at the beginning. So it's kind of deviating from 2 of the most important experiences. Did it start up quickly, and did it look good? And you're missing both of those when you do that. So to avoid a stall, the idea is to download the video faster than it plays back. So you can see the buffer filling up. And this video is good. You know, we've already filled up the whole buffer while the video is still playing. When it stalls, it's playing back faster than it can be downloaded. So in this case, you know, we've hit a stall, right? There's no more video to play. We're waiting for more video to come down. There's no video in the buffer. But that's not the most annoying part. The most annoying part is this one, where now you can see there's video in the buffer, but it's not playing back. And the reason it's not playing back is the player knows it's just going to stall again in about 2 seconds. And so if you're like me, you hit play and you watch the 2 seconds and then it stalls again and you press play and then you just slowly make your way through the video. But it's not a great user experience. And so it's really important that you balance the available streams to be able to handle most network conditions and be able to download the content faster than it plays back. Here's a list of video streams that was in a manifest file I found. And right in here is a problem. And the problem is there's like a 3x jump in these 2 bit rates. And so there's such a change in quality right there at those 2 different bit rates. We had some streaming issues. And so what happens is it starts downloading. It actually started out here at this really high bit rate. It goes to the low bit rate. And then it kind of gets stuck. This one's too low, but that one's too high. And it keeps bouncing back and forth between these 2 bit rates. And what ends up happening is instead of downloading segment 7, 8, 9, 10, 11, building out that buffer to prevent a stall, you can see segment 5 is downloaded 3 times. Segment 6 is downloaded 3 times. The player's getting so confused, it's downloading the video in a duplicate manner. And it could lead to a stall because the buffer hasn't filled up. It's just downloading the same stuff over and over again. All right. So in conclusion, the way to speed up content that you're delivering to the web is no redirects and make everything small. If you can make the things that you deliver as small as possible, compress the text files, optimize your image delivery, and optimize the video you're delivering, it's going to get delivered to all of your customers faster. It'll show up on the screen faster, and they'll be able to use the content faster. So the tools I use web page test. For the web, I used Video Optimizer for Android and iOS apps. I wrote a book for O'Reilly called High Performance Android Apps. If you're interested, that's the PDF, so you can download that as well. And then I talked about how to optimize images with Cloudinary. It's a cool service, so you should check that out too. And with that, that's the end of my talk. So I'll be happy to hang around and talk and take any questions. Thank you very much.
So thank you.
Thank you.
Very nice slide and talk. And yeah, so now we're gonna start with the beers and hanging out and the networking thing. And feel free to ask Doug something
Great.
if you want. And that's it. Thank you for coming.
Thank you.
I have a question related with this morning. I have been reading the release notes of the Android Studio 3.2, and they were talking about the reduce of the size of the APKs.
Okay.
And I was thinking, about the instant apps and that Google is moving to do little packages of features, in the modules. And I was thinking while you were talking about the emails and so on, that maybe this is the path that they want to take in order to be able to buffer in the apps in real time and try to identify the device and deliver different packages. I don't know if...
So it's the idea they're delivering different, so we're delivering different packages instead of the APKs. Can you just update one package as opposed to the whole APK? I'm trying to remember.
You download them on demand.
Okay.
A core module, and then
Okay.
explore new features inside the app, you download
Nice.
the rest.
So that's, I mean, they talked about doing that in like Jelly Bean, right? Where you could only update parts of the application instead of the whole application. So, you know, I'm sure they've been working on this for a long time. So yeah, anything you can do to, I mean, there's two things there. One is, if you are updating it, you don't have to download the whole app, right? So that's going to make it easier to do the updates, but two, it's not going to use as much data if you do your updates over cellular, or if you're doing it over Wi-Fi, it'll still be faster. So it lets you probably iterate faster. You know, I know there are a lot of things out there that let you change it on the back end, so you don't have to update your app. But if you can iterate on the native code faster, that's huge as well. But yeah, I mean, one of the reasons you see a lot of APKs get really, really large is, you know, you put the images in your app and people just put all of the images, you know, you start, if you go into them, you can see sometimes all of the images that are there and they're just huge. Just, you know, they have the ginormous images in the app, and that can obviously lead to some of those giant APKs that we have to download every week or 2 weeks as they update.
Well, they changed that a bit too. They have another thing called App Bundle now.
Mm-hmm.
Basically, you give them everything you have,
and they will bundle
they will
it.
decide what you download on your phone. So you
By
won't
language, screen size, and
right, so they can.
Yeah, you won't get densities you don't need.
So you don't get the TV size
Yeah,
images
yeah,
because it used
XX,
right,
yeah.
exactly,
Yeah.
and the right localizations, which totally like there's no reason to be downloading the Chinese character set for probably most of us here in the room. I don't know.
Yeah, and also we're thinking about, I don't know, about the ability to do different packages,
Yeah.
or how they call features.
Mm-hmm.
Maybe in the future they can allow to identify which device, processor, RAM memory, and so on,
Right.
and deliver different features for the different users.
Right.
So maybe everything is also focusing to performance.
I mean, that will come. I mean, if you think about, Facebook has Facebook Lite. Right. And so they have a version of their app that you can only get in certain areas of the world where the networks are slow and the phones are generally slower. Right. So, I mean, that would obviously be ideal. Right. You can do that with web pages. You can do with the requests. You can say, well, this is a slow connection, so give me the lower quality video. These are all things we can do today in our apps or in our web pages. But it'd be great if, you know, obviously, if it becomes more standardized, that it's happening as you build the application at Google Play, or if the browser's taking care of it for you. That makes all of our jobs a little bit easier, doesn't it? If it can be taken care of by the, you know, and it helps us as users too, because if every single app developer is following that same thing, that optimization is happening for everybody, and that's great.
Do you have any experiences with this Android to Go? Like, when they introduced it, I heard that they will have like different like Google Play store, and they will have like applications with the suffix Go. And
yes.
You can download them.
So everything I've seen on the web is you should buy one and check it out. And I almost pulled the trigger and I almost bought one. I probably will next time I'm in a store. But like I said, they're about 60 euros. So they're not going to break the bank if you do, but they're super slow. So they've got like, most of them have like 512 megabytes of RAM. The processors, as one guy on Twitter says, they're straight out of 2014, right? So we're going 4 years backwards in terms of processor speeds. And yeah, Google Maps doesn't run on it. So there's Maps Go and there's Gmail Go. And because the app, you know, Google Maps is just too big and uses too much memory to run on that device. So they actually had to, you know, just like Facebook has Facebook Lite, they had to make Maps Lite essentially to run on these devices.
So as a developer, can I like choose that I would like to make, let's say I got an application or I don't know, Microsoft Word, for example, and I would like to make a Pro version. I can make it and publish it only on this app store. Only for I
would assume if Google has a way to do it, I would hope that it would be open to everybody, but I don't know. I don't honestly know if there's a way to make that work. But I've seen a lot of people who do web stuff, and a couple of people have like, I carried one for a week and I wept that entire week. You know, you read the reviews online and it's like, it takes 6 seconds for the camera to turn on, right? and by then your kids are like 3 blocks away. So yeah, I'm gonna have to get one and see just how miserable it is. But from what I understand is, yeah, like a lot of the applications that are built today to run on the phones that we, as developers, we tend to carry, from the last couple years, a really high-end device, which is still more high-end than most people are carrying. And so it's important to remember that there are people, hopefully not a lot of people on these 60-euro devices, but there will be some. And we have to think about how our app will work on that for those customers.
You mentioned that they're expecting the US to be the second market.
Mm-hmm.
I'm guessing the first one is India, or?
So I don't actually know, but
like,
yeah, I'm guessing it's going to be India or China or a market where, inexpensive smartphones are important. But obviously it's important in America too. The last time, just like here, there's, you go into the stores and it's like a store you wouldn't expect to find mobile phones, and like, there's a stand like in the grocery store, there's a stand of phones, and they're all really, you look at them and they're like, oh, that one's still running Android 5.1 and they're selling it as a new device, but it's in the grocery store. The people who are buying a phone there don't know that 5.1 is like 4 years old or something like that, right? They just don't have any knowledge of that. So they're basically buying Android Go phones. It's the phones that didn't sell that end up at 3 years ago that end up, at these, where people buy these devices.
I think that happened to me sometimes, because when you have a operating system update, you always read performance improvement, and so on, but every time you update the phone, your phone is slower. So I don't know how they always say, if you phone have more than 2 years old, better don't update the OS, because they are going to screw you. And it's like, I don't understand how they always say that the performance is better, but always the phones work worse.
Yeah, they're adding stuff that will make it faster. But I mean, you read about the new Apple phone and it's faster than, it's definitely faster than my Mac, right? The CPU on the new iPhone is faster than our Macs, right? So they're making the OS so fast, but if you're 2 generations behind that device, I mean, it's going to look slower. But yeah, they are. I mean, and I know Android is constantly working on improving the performance, and every year you see the new performance improvements. I do know at AT&T, the #1 reason why devices were returned was battery life. And I also know that what they would do is you couldn't keep the private data on the phone, so they'd have to wipe it and then test it. And most of the time it wasn't the hardware. Like 98% of the time it wasn't the hardware, which just means that there were apps that were on there, or they were on Facebook all day, right? And if you're on Facebook all day, sure, the battery life is going to be horrible because you're on Facebook all day. So I wonder what happens to those people. Do they just come back like 2 weeks later? Because they're just installing the same apps on their new phone, right? Unless maybe they're like, oh, I never use that app. No, I won't. When you update to a new phone and they're like, would you like to move all 150 apps over? And you end up only moving like 60 of them. You have to assume that, some of those other apps were actually what's causing the battery delay.
Any more questions?
Awesome. Cool. Thanks, guys.